learn the step response of the system. So the step response of the system is nothing but for a system with an impulse response h of t. If x of t is applied, it gives y of t is equal to, we know it would be x of n convolution h of n or h of t convolution x of t, or it would be r x of n convolution h of n. Now, if the input of the signal, if the input of the system is equal to the step signal, it may be a continuous or a discrete. It may be a continuous unit step signal or it may be a discrete step signal, that is u of n. So it may be u of n or it may be u of t. If u of signal is applied, then whatever is the response of the system, that is y of t, it is convolution of the input and the impulse response of the system, or it is h of t of the system, is nothing but the step response of the system. The step response of the system is the response of the system to a unit signal, When unit signal is applied, whatever is the response, if it is discrete, then u of n, h of n. If it is continuous, then u of t, h of t. So in that case, the y of t is the convolution of the input and h of t. But here our input is either u of t or u of n. So our y of n is the convolution of u of n signal with h of n signal. And if we reverse, it becomes h of n convolution x of n, because the commutative property is always true. And when we expand this convolution expression, the summation k from minus infinity to plus infinity, h of k x of n minus k, even the u of n convolution h of n or x of n convolution h of n is also true. And to understand and to find the equation for step response, let's consider this equation. Now, when the input becomes u of n, the response y of n, the response y of t, or it is y of n, is referred as s of n. When the input of the system is the unit step signal, then the response is referred as the unit step response, which is given with the following equation. Now we know that our x of n, our x of n minus k, we need to consider. Our x of n is nothing but u of n signal. It is a unit step signal, as we are already familiar with this. It is the signal having one amplitude and running in this way, a discrete signal with all unit samples from 0 to infinity. When the x of n is u of n, x of n minus k, already we know the nature of the x of n minus k. X of n minus k, when we convert, when we do indexing and when we go for the time reversals and all, we'll get this kind of a signal. Let's write x of n minus k signal. And this x of n minus k signal is running from 0 to minus infinity for the time being. And this signal is getting convoluted with h of k. And this h of k, let's say it is the unknown signal. It will be given in the problem. Let's say it is unknown. Now let's consider that this x of n minus k signal. This x of n minus k signal can take two values. This x of n minus k signal can take two values. N minus k can take two values. This is equal to 1. Either x of n minus k can be equal to 1 or it can be equal to 0. When x of n minus k is equal to 1, then the summation is nothing but k from minus infinity to plus infinity, just h of k, because x of n minus k is 1. And when x of n minus k's value is 0, that time this s of n is equal to 0. So this, what is this x of n minus k? We know that n minus k. So k is nothing but the variable, and n is nothing but whatever the value we take and which decides upon how our x of n minus k is located. If this n is positive, it will be moving on the right side. If n is negative, it will be on the left side. The signal is going to shift on the left side, like that. So x of n minus k, the first and foremost thing is this x of n minus k, this n minus k term. We should have x of n minus k, rather let's write it as this x of k, x of signal is nothing but our x of n signal is u of n signal. If x of n is equal to, if our x of n is equal to u of n, then our x of n minus k, x of n minus k is nothing but u of n minus k. It is our u of n, it is our u of n minus k signal. So let's draw, it is our u of n minus k signal. So better consider this x of n minus k as u of n minus k signal. This u of n minus k signal, u of n minus k signal is going to be 1 when this n is greater than k. Because when we have, like for the signal, so the signal is going to take up the value as 1 when u of 0, u of 1 means whatever is the quantity, whatever is the variable inside that bracket has to be greater than or equal to 0. Means its value u of n minus k is equal to 1 when n is greater than or equal to k. So as long as our n is greater than or equal to k, we'll get u of 0 or u of some positive values. Otherwise, if our n is less than k, if the n is less than k, then we'll get the value of this one as, we get n is less. N is less means we start getting u of minus 1, minus 2, because n is less than k. So in that case, so its value is going to be 0. So the condition for the existence of this s of n is the s of n is equal to summation of k is equal to minus infinity. K is equal to minus infinity. Now what about the upper limit? The upper limit, now it is with respect to k, but if k takes the plus infinity value, certainly it would be greater than n. And in those cases, our condition would be like n is less than k and it would be 0. So our summation has to be from k minus infinity to, let's say, let this k take a value equal to n, because the maximum value the k can take is n. When the value of k is n, that time we'll get u of 0. And if n becomes less than k, that time u becomes u of, we start getting u of minus 1, minus 2. So our signal will be 0. So the maximum value the k can take is n. So this equation turns as k from minus infinity to n, it is h of k. And certainly it takes care of all those requirements. Now as we can see, and as we are familiar with the step response problems, now if the unit step signal is being considered, and whatever may be our h of k, whatever, if depending upon the value of our x of n in those cases, now it would be h of k. So it would be, if it is coming up to n, then from 0 to, like that we used to study. Now we don't know the range of x of k, so let's consider it from minus infinity to 0. So minus infinity to from minus infinity to n it is. So the step response of the system is given by s of n, and it is the summation k from minus infinity to n h of k. So whatever is the answer we get out of it, it will be just the result of the step response. Now it is the shortest method to find the convolution of the given h of n signal with the step signal, because already the other signal, that is our input, is by default the step signal. Means if we want to do the convolution of any signal with the unit step signal, then we can use this equation and we can find its solution. So and this example is with respect to the discrete signals. With the continuous signals also, the same thing applies. We have the nature of x of t minus tau signal, and it would be 1 if t minus tau is equal to 0 or greater than that. If t minus tau is less than 0, then it would be u of t minus tau. We start getting u of minus values, which makes it as 0. So the condition for step response in case of the continuous signals is s of t is equal to the integration from minus infinity to t here, h of tau d tau. Now we can solve this kind of problems. The very first problem, as we are familiar, we can consider let h of n is equal to half raised to n u of n. Let the first problem is equal to h of n is equal to half raised to n u of n. So let's consider half raised to n u of n. Anything we can consider, just I can remember this half raised to n u of n. Then what is the step response of this signal? The formula is this one. The step response is represented by s of n, which is equal to summation k from minus infinity to n, from minus infinity to n, half raised to now h of k it is. Means, just for understanding, no need of drawing, but will draw the signal. Let's say half raised to n u of n signal. As we are familiar, half raised to n u of n means it runs from 0 onwards up till infinity, and it is half raised to n. Half when n is 0, so it is half raised to 0. The value would be 1. So this is our h of n signal. So its value is 1. When n is 2, it is half raised to 2, which is 1 by 2 the square, which is 1 by 4. Like this, it would be a bit lesser in magnitude. Then when n is equal to 2, it is half. When n is equal to 2, it is 1 by 4. Like that, the values go on decreasing as the n increases. So it is a decaying sort of a discrete exponential signal. Now this signal, the formula is h of k. Now just to do the indexing, the same signal, let's represent it as h of k signal. The same signal is represented as h of k, and in place of this n, it is represented as k. So the same signal it is. So we understand that it is this kind of a signal. It is at h of k at 0, 1, 2, like that. So it will be given by half raised to, now when we do indexing, so this h of k is represented as half raised to k into u of k. Half raised to k u of k. Half raised to k u of k, as it has been reflected by the signal. The signal runs from 0 onwards. So no need to write. So let's write this u of k. Now when we go for solving this one, we know as u of k is multiplied, the k from minus infinity to n will not take place because our signal is just running from 0 to infinity, and even though the h of n minus k, that other signal, is from minus infinity to 0 or maybe on the other side, it doesn't make any difference. So u of k is multiplied means the summation will run from k is equal to 0 because u of k stands for 0. So as u of k is multiplied, let's change this lower limit from minus infinity to 0, and this would be n. So it is half raised to k. Now to solve this, the equation we use is, we know that there is a summation alpha. Let's take any variable, let's say it is k. If k is equal to 0 to n and alpha raised to k is there, we have already used it in convolution. So it is 1 minus alpha raised to n plus 1 divided by 1 minus alpha raised to n plus 1 divided by 1 minus the alpha. So by using that, so it is given by 1 minus 1 by 2 raised to n plus 1, the limit plus 1, it has to be divided by 1 minus 1 by 2. We can solve this one, simplify this one, and we can write up the answer. This 1 minus 1 by 2 is nothing but equal to 2, and in bracket we can write this is 1 minus means 2 let's write 1 minus 1 by 2 raised to, or in any of the simplified form, this would be the solution of the equation, n plus 1. We'll see some other problems in the next videos. I hope you understood what is the step response. The step response is the response of the system for an applied unit step signal. Either it may be a continuous or discrete. So in case of continuous, it would be s of t is equal to the integration from minus infinity to t h of tau theta. And in case of discrete, it is from s of n summation k is equal to minus infinity to n h of k. So whatever is the solution of that one, we need to get. And by default, it is the convolution of the given h of signal with the u of t or with u of n, depending upon the given signal, whether it is discrete or continuous. So we'll see the next kind of problems in the next videos.